Alright, so last time I showed you how to write a program that solved Pythagorean Theorem for the hypotenuse of a triangle. However, you're not always going to need to solve for the hypotenuse of the triangle. Sometimes you're going to need to solve for one of the legs when you are given the other leg and the hypotenuse. Our other program could only solve for C, so solving for A or B, we wouldn't be able to do that with that program. So this time, I'm going to show you how to write a program that will solve for any side of the triangle when given the other two. So, we have our triangle. We have A, B, and C. So let's say we are given A and C. So we need to find B. So we have A squared plus B squared equals C squared. So, since we need to find B, we need to isolate B on one side of the equation. So I'm going to subtract A squared from both sides. So now we have B squared equals C squared minus A squared. Now close, we have B on one side of the equation and the other two variables on the other. However, we still have a squared sign under the B. So I'm going to take the square root of both sides. So let's come down here and I will have now, once I take the square root of both sides, I will have B equals the square root of C squared minus A squared. Right, so that's the formula that we are going to use when we are writing this program. We will also need to do that, but with A. So if I were to isolate A on one side of the equation, I would have A equals the square root of C squared minus B squared. I hope you followed what I did there. I just subtracted B to this side of the equation, and then I took the square root, just like I did before. So we will need both those formulas and the other formula that we had in the previous video. So, now that we have that, let's do some code. So, I'm just gonna throw in a new sheet of paper here, one sec. Alright, that's upside down. So the code. So we have our calculator. We need to start writing the code. So I'm going to tell the calculator, remember these colons? Those colons denote a new line of code. So we have prompt A, B, and C. So if you remember from the last time, that is, the calculator is going to ask me what the value A is and what the value B is. However, this time, in addition, it is also going to ask me what the value C is. So, then after that, our next line of code will just be if C equals 0. So this time, if you remember last time, we just have value A, value B, and then it does some math, and it comes out with C. This time it's going to prompt us on all three of them, and for the one variable that you do not know the value for, I'm going to put in 0. I'm not going to tell it that that value is 0, because obviously if you have a triangle, one of the sides cannot be 0. So, if the value is 0, the calculator says, hey, that's the one I'm solving for. So, if C equals 0, then, it's quite a long line of code, then, next line of code, the square root of A squared plus B squared, and then we're going to store that as C. So if you remember the store that's in this program, the square root of A squared plus B squared is C. Okay, so that's the first part of this code, this program. If you remember, that's very similar to last time. So our next line of code is going to be the word else, which these commands, the if, then, else, those can be found in the logic commands section of the program calculator. So else if A equals 0. So when you put in your variables A, B, and C, it's going to say, hey, is C 0? If the answer was yes, then it's going to do this part. If the answer was no, it's going to skip down here to the else and say, hey, A is 0. So now we're going to A equals 0, and our next line of code is going to be the root of c squared minus b squared, and we're going to store that as a. So now our calculator knows that if a was 0, we're plugging, this is the math that it's going to do, and it's going to store that as a. Alright, now, looks like I've kind of run out of room here. Just throw another sheet of paper on top of this. Yeah, that works. Now, our next line of code is if b equals 0. So if you remember, we have, if c equals 0, no. Then, does a equal 0? Let's say the answer is again, no. Then it's going to skip to this last one, b equals 0. So if b equals 0, next line of code is the square root of c squared minus a squared. And we're going to store that as b. Alright, so we have that stored as b. Now I'm going to tell the program to end. So computer end program. Then our very last line of code is display a, b, and c. So we have our program now. So it's going to prompt A, B, and C. I'm going to put in 2 actual values for whichever 2 I'm given in the problem, and then I will put in 0 for whichever one I'm not given. And then it'll say, if C equals 0, we're going to do this. Otherwise, if A equals 0, do this, and if B equals 0, do this. Then we end, and it will display A, B, and C. So I'm going to pull out my calculator here. I'm going to go to Program. That's kind of hard to see, sorry. I'm going to go over to Edit, and then I'm going to go to 3 for Lucas. And if you'll see, that is the code that I have written down here. So I'm going to quit. I'm going to go back to Program, and I'm going to go to Execute 3. So it's going to say, hey, what is your value for A? In this problem, I want to solve for A. I'm going to hit, oops, sorry, I have to hit 0. And I hit enter, B, that's a given, 4, C, also given, that's 5. So I hit enter, and it spits out 3, 4, and 5. So it solved for A, and it was 4. If you'd like to check that, let's do that. Let's check that. So, A squared plus 4 squared equals 5 squared. So that's A squared plus 16 equals 25. If we subtract 16 from 25, so we got 5 minus 16 equals 9. 9, the square root of 9 equals 3. So, if you'll remember, 3, 4, and 5, those are the values we had. That's great, our program works.